Welcome everybody. My name is Carsten Worm, and in this short teaser video I would like to introduce to you the topic and results of my master thesis called BPMN and Data Model Extraction using Process Mining Techniques. To summarize the goal in one sentence, what we would like to do is use MontyGem in order to generate a process-aware information system. MontyGem is a generator framework which uses a different set of input models in order to automatically generate the code for a web application. And what we would like to do is to generate a process-aware information system in particular. Now, everything you can see on this image has already been implemented. In particular, with respect to this number 5, you can see that it is already possible to use MontyGem to generate a process-aware information system by providing as one of the input models a process model. Now that process model needs to be a BPMN process model, and it needs to be represented in a textual domain-specific language. This poses two main problems. First of all, it is assumed that the process model already exists to begin with. This most of all has the issue that the process model would need to be translated into the textual domain-specific language, and that translation has not yet been automated. So this would have to be done by hand by the user, which is certainly prone to errors. The second issue is that with a theoretical process model, we always have the concern that the theoretical model might not accurately model the real-world behavior of the process. These two issues are what I addressed within my master thesis. I propose to use process mining techniques to both automate the extraction of the process model and the translation of the process model into the domain-specific language. So first of all, I replace the process model as a starting point by an event log. An event log has the major benefit that it is recorded during the execution of a process and therefore consists of the real event data of the process, representing the true behavior of the process. I then implemented a tool represented by this red dashed area, which uses discovery techniques from process mining to first of all automatically extract a BPMN process model from the event log, and then automatically translate that BPMN process model into the textual domain-specific language that MontyGem can work with. In addition to that, if the event log contains resource behavior, that means if we have information for each event about which resource performed that event, then the tool is also able to automatically extract a role model file, so a list of roles, and for each role a list of tasks that are grouped together under that role. And in the translation process, we are then able to respect the discovered roles in our DSL representation of the process model. Lastly, the tool can also perform additional analysis steps on the event log to provide the user with more insights into the underlying process. The tool itself then consists of 5 different modules. First off, we have the model extraction module, which is the only module written in Python, because this module makes use of the PM4Py library, which has the implementations of all the process mining algorithms that we need, and that library is a Python library. So the model extraction module will automatically extract a BPMN process model from the event log, and also extract a role model file given that the event log contains resource information. The second module is then a preprocessor. The preprocessor fixes some issues that the extracted BPMN process model necessarily has. Third is then the translator. The translation module creates our BPMN process model representation within the textual domain-specific language. Fourth is the additional analysis module, which performs the additional analysis steps on the event log to provide the user with additional insights into the underlying process. 2 examples are a handover of work matrix, which gives the user an idea into which resources are commonly handing over work to which other resources. and a resource activity matrix, which gives the user an insight into which resources are performing which activities in the underlying process. The last module is in a command line interface, which processes different kinds of command line arguments to give the user the ability to trigger particular parts of the tool depending on what their needs are. I can give you a short demo. Here we have an event log that we would like to use as our starting point. And here is our Python script. So this is the first module, the model extraction module. On top here we have some constant variables where we can define the path to the input event log and the paths to the desired output locations. Running the script, you can see that we have automatically generated a BPMN process model and the generated role model file from the event log. So in this role model file, you can see that we have discovered 3 different roles, which you could now go ahead and rename. And we can see that for each role, we have a set of activities that are grouped together under that role. I can then go ahead and copy the event log, the generated BPMN process model, and the role model file into the Java project where our remaining modules are at. So here I have the generated BPMN, here I have the event log, and here I have the role model file. I am now within the command line interface module, and I am using Maven to define the paths to the 3 files. I define the paths as properties, and then use the Maven execution plugin to hand over those paths to the command line interface. Of course, you could just run this on the terminal as well and give the paths manually. Running this, you can then see that it runs in just over 1.3 seconds. And within the generated sources folder, we then have our output files. We have the pre-processed version of our input BPMN process model. We have the domain-specific language representation of our process model, which can directly be used as an input model to MonteGem. And we have an analysis HTML file, which contains the results of the different analysis steps that the tool has performed.